In this episode, we're going to look at how to verify IPv4 and IPv6 addressing. I'll show you how to do it, and we'll talk about the concepts along the way. Dual stack allows IPv4 and IPv6 to coexist on the same network. We'll investigate the dual stack implementation, including documenting the IPv4 and IPv6 configuration for end devices, testing connectivity, both IPv4 and IPv6 using ping, and then finally tracing the path from end to end for IPv4 and IPv6. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Verify IP version 4 and IP version 6 addressing. I have the Packet Tracer lab open on the left side. That's where we're going to go in, do our configurations, look up information about our devices. On the right side, on the right bottom, I have our standard Packet Tracer activity window open. We can go in there, we can see our configurations. There's no results to check on this one. In the upper right, I have the Word document. The reason I have the Word document open up is we have to go in there, fill in some fields. We have to fill in some of the fields in the addressing table. There's several questions at the end to answer. This will allow me to put my information in there and save the document. Here's our addressing table. As we look at our addressing table, we can see that we have 3 routers over here in our working area. We have 3 routers here. We have 2 PCs. We got one on the left side, one on the right side. We're not really worried about the configuration of the switches for this lab. Here we have IP addresses. We have our interfaces. They have IP version 4 addresses with subnet masks. They have global unicast addresses with prefixes. And a couple of these interfaces even have link local addresses. Our objectives: complete the addressing table and the documentation. Down here we need to fill in these fields. Test the connectivity using ping. Discover the path by tracing the route. Part 1. Complete the addressing table. Use ipconfig to verify IP version 4 addressing. Click on PC1. Over here I'm going to go ahead and click on PC1. And open up a command prompt. Go ahead, click on command prompt, opens it up. Here we go. Enter in the ipconfig /all command. IPconfig. There's no space in there. It's all one word. Space /all. Hit enter. And it displays a bunch of information for us. Fill in the addressing table with the IP version 4 address, subnet mask, and default gateway. Okay, so up here for PC1, they want us to fill in that information. IP version 4, we'll put that in the top row. Here is our IP version 4 address, 10.10.1.100. 1.100. This column here is a subnet mask. If we look here, here's our subnet mask, 255, 255, 255.224. At 224. And then this last column here is our default gateway. Our default gateway is the next line down right here. Here is our default gateway, 10.10.1.97. 10.10.1.97. That is all 3 fields we need to fill in for IP version 4 on PC1. That takes care of part 1, step B. Now on to C, click on PC2 and get that same information from the ipconfig /all command. Click on the command prompt, IPconfig, once again, all one word, no space, /all. Here's our IP version 4 information. We'll scroll up here. We are on PC2. Our IP address 10.10.1.20 10.10.1.20 subnet mask of 255.255.240. And our default gateway of 10.10.1.17. 10.10.1.17. Look at these addresses. These are all really close, a lot closer than we've been working with. Typically, we work with a class C, the /24, but these are more. We're looking here at borrowing more bits, making smaller networks. These are actually on different networks. Part 1, step 1 is done. We have that information all saved. On to part 1, step 2. Use IPv6 config to verify the IP version 6 addressing. Same thing as the IP config, but we want the IP version 6 information. IPv6 config gives us that information. I'm going to go ahead on PC1, enter in IPv6 config /all, fill in the address table with the IP version 6 address, the subnet prefix, and the default gateway. Go up here to our addressing chart, click on PC1. The command IPv6 CONFIG. Once again, notice all one word, no spaces. Space /all. Here is the same information, but for IP version 6. First thing we have to enter in is our IP version 6 address. That's the one that starts with 2000. 2001:1:1:1 We're also supposed to put the prefix in there, /64. We get that. And then the last column here is our default gateway. Our default gateway is listed right here. Is a link local address of our router. FE80::1. That is standard practice to give that specific address. FE80 signifies that is local link addresses. They won't get routed on the internet. And to give the first one to your router. That is standard practice. Make sure you follow that. That takes care of PC1. Now we need to do PC2. Go ahead, click on that. Open up our command prompt. Type in IPv6 CONFIG, all one word, no spaces. Here we have our information. This here is our IP version 6 address. This is our global unicast address. 2001:1:4:A. We need to put our prefix on there, /64, and then our default gateway. Here's our default gateway. A little bit different, FE80::3. That is our default gateway, FE80::3. We have now filled in all the blanks on our addressing table. That takes care of part 1. On to part 2. Test the connectivity using ping. So what we want to do is use the ping. From PC1, ping the IP version 4 address of PC2. I'm going to go ahead, open up PC1 here. Click on command prompt. Type in ping and then get the IP address for version 2, IP version 4 address for PC2. That is right here, 10.10.1.20. Go ahead, type that in, 10.10.1.20. Hit enter. And should hopefully work. There it is. first one timed out. Why did the first one time out? You are typing in ping, and then you put in an IP address, a layer 3 IP address. Remember how devices communicate when it goes from one device to another device, one networking interface to another. It uses the layer 2 MAC address. And what had to happen is we needed to translate that layer 3 address, the one you typed in ping and you put your layer 3 IP address in there. We had to translate that and find what was the MAC address of that IP address, or the next hop to get us closer. That was the ARP process. And so it looked up that MAC address. It failed. If we repeat that command, it should work all 4 times. Repeating the command is fairly simple. Up arrow once, hit enter. There you go. And all 4 are going to complete. Part 2, step 1A. Was the result successful? Yes, it was. From PC2, ping the IP version 4 address of PCA. Open up PC2, command prompt, ping, and then we'll scroll up to our addressing table and ping the IP version 4 address of PC1, 10.10.1.100. 10.10.1.100. There it goes. Now, notice it didn't fail that time because it knew what the MAC address was. It had to send an echo reply already. It went through the ARP process already for that. Part 2, step 1B. Was the result successful when we went from PC2 to PC1? Yes, it was. There we go. Step 2, use ping to verify IP version 6 connectivity. Ping PC1, or from PC1, ping the IP version 6 address of PC2. Open up PC1, have our command prompt up there, type in ping, scroll up to our addressing table, and get the IP version 6 address of PC2. That's right here. Go ahead, type that in. 2001:DB8:1:4:A. Notice it did not fail. IP version 6 does not have to do an ARP lookup. That is one of the efficiencies of IP version 6 over IP version 4. Scrolling down to our question, part 2, step 2A. Was the result successful when we pinged PC1, PC2 using IP version 6? Yes, it was. Now, do it the opposite way. From PC2, ping IP version 6 address of PC1. Ping, I'm going to scroll up and look at my addressing table. Here is that address. Ping 2001:DB8:1:1:A. And there we are. Ping is successful. I'm down here, part 2, step 2. Was it successful? Yes, it was. On to part 3. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Part 3, we're going to use Traceroute here. Use Traceroute to discover the IP version 4 path. From PC1, trace the route to PC2. They give us the command. Let's go ahead, get back on PC1. I hit enter a couple times just to give me a clear working area. Enter in this command. Traceroute, or Tracert 10.10.1.20. That's the IP version 4 address of PC2. Trace RT 10.10. Whoops. We'll start that address over. 10.10.1. Okay, let's start it over a third time. We'll get it right. 10.10.1.20. And here we go. Traceroute gives us the path. It tells us every device we go through to get to our destination. As we look here, when we go from PC1 to PC2, we go from PC1 into R1, then we go into R2, and then we go into R3, and then finally to PC2. That's what's happening right here. What addresses were encountered along the path? Type your address here. Well, first address we had was 10.10.1.97. Then the second address was 10.10.1.5. The third address was 10.10.1.10. And the final address was 10.10.1.20. The address we actually did the trace route to. With all interface with which interface are the 4 addresses associated? Okay, well, we're gonna have to look this up into our addressing table at the top, but we're looking for 10.10.1.97. 10.10.1.97 is right here. It's actually on R1, the gig 00 interface. And so that was the first one we had. That was G0/0 on R1. Then the next IP address, 10.10.1.5, 1.5 is right here. That's on R2, serial 000. Serial 0/0/0, 3 zeros on R2, was it? Yep, on R2. There you go. Then the next one was 10.10.1.10. If we scroll up here, 10.10.1.10 is the serial 001 interface here on R3. Serial 0/0/1 on R3. And then finally 10.10.1.20. 10.10.1.20 here is PC2. It's the NIC on PC2. That's the NIC on PC2. Once again, that went from, we started at PC1, then we went to the gig 00 on R1, gave us a report back saying it responded fairly quickly, 0 milliseconds, 1 millisecond, 0 milliseconds. The next step here was this IP address, which turned out to be serial 000 on R2. Now we're on the second router. That's where our pings were going to. The third one was serial 001 on R3, which is right here. And then finally, the last one was our destination, was the NIC on PC2. That was it. And so we were able to see the path going through the network. From PC2, trace the route to PC1. Okay, let's open up the command prompt on PC2. Hit enter, give me a clean working area. Once again, it was trace RT is the command, and then we want the IP version 4 address for PC1, which is right here, 10.10.1.100. 10.10.1.100. And as you can see, we went through and we got 4 addresses. And the question reads, what addresses were encountered along the path? First address was 10.10.1.17. Second address, 10.10.1.9. Sorry about that. Third address was 10.10.1.6. And the last address was our destination of 10.10.1.100. With which interfaces are these 4 addresses associated? Once again, we have to go and look this up in our table. First address here was 10.10.1.17. If we come up to our table, 10.10.1.17 is right here, which is gig 00 on R3. Gig 00 on R3. The second address, 10.10.1.9. 1.9 we're looking for. 1.9 is right here. That's the serial 001 interface on R2. Serial 0/0/1 on R2. The third IP address, 10.10.1.6. 1.6 is right here. That's the serial 001 interface on our R1, serial 001. Serial 001 on R1. And then the last IP address, 10.10.1.100. If we scroll up here, that is the IP address of our destination. That is the NIC on PC1. Is the NIC on PC1. There you go. Let's just look at that route one more time. We started on PC2, the trace route. The first hop was right here to this interface on R3. Then the next address, as listed here, would be on R2. That's what we came up with right here, serial 001 on R2. That's this interface. The third address, listed right here, 10.10.1.6. When we looked it up, came up to serial 001 on R1. That is this interface right here. And notice each time we're going out further and further. And then finally, the last one in our trace route is 10.10.1.100. When we looked it up, that was the NIC on PC, and so that was our destination. And that's how our trace route works. Step 2, use Traceroute to discover the IP version 6 path. From PC1, trace the route to the IP version 6 address on PC2. You're going to connect into PC1 here. Once again, we are in the command prompt. Command here is trace route. It's the same command whether you're using IP version 4 or IP version 6. You just put an IP version 6 address in there. 2001:DB8:1:4:A. And there is our trace route. Once again, notice it was a little bit quicker because we don't have to go through the ARP process. And so, what addresses did you encounter along the path? Well, the first address we encountered is 2001:DB8:1:1:1. Second address was 2001:DB8:1:2:1. Third address was 2001:DB8:1:3:2. And the last address was 2001:DB8:1:4:A. Those were our 4 addresses. With which interfaces are the 4 addresses associated? And what we have to do is take this address, look it up there. As we quickly look here, we're just looking for the last 2 numbers. All the rest seem to be the same except for our subnet ID and then our identification ID. I'm going to go up there, look for an IP version 6 address that has a 1:1:1. In our addressing table, here's a 1:1, and that is the only one in our network. And so that was assigned to R1G00. G00 on R1. This address was 2:1. 2:1 is right here. That was assigned to the serial 000 interface on R2. Serial 000 on R2. Third address right here ends in a 3:2. Looking for a 3:2. Right there it is. That is on the serial 001 interface of R3. Serial 001 on R3. And our last IP address ends in a 4A. Looking through here, we're looking for a 4A, 41. Here's a 4A. 4A is the NIC on PC2. And NIC on PC2. Yep. On PC2, trace the route to the IP version 6 address of PC1. Gonna go ahead, open up PC2, get it back into the command prompt here, hit enter a couple times to give me a clean working area. Ping, and then I need the IP version 6 address of PC1. Come up here to our addressing table. Here is the IP version 6 address of PC1. Go ahead and type that in. Starting over 2001:1:1:1:A. And we get 4 successful pings, but I was supposed to do a trace route. TRACRT space 2001:1:1:1:A. And there's our trace route. Showed you the ping work, and here's our trace route. Coming down here, what addresses were encountered along the path? Okay, first address is right here. Go ahead and type that in, 2001:DB8:1:4:1, comma, or on to the next one. It's 2001:1:3:1. The fourth address right here is 2001:DB8:1:2:2. And the final address is right here. 2001:DB8:1:1:A. Last question, with which interfaces are the 4 addresses associated? Once again, we have to go up and look that up. I'm going to look at the last 2 numbers in our IP version 6 address. Here we have a 4:1. Scroll up to the top, look for a 4:1 right here. That is associated with gig 00 on R3. So gig 0/0 on R3. It's the first one. Here's the next address. I'm just going to look at the last 2. The reason I'm getting away with that is we have a small network, and the network was set up to make these unique on all the interfaces. So I'm looking for a 3:1. Coming up here on our chart, we're looking for a 3:1 right here. That turns out to be serial 000 on R2.
No, what was it? Serial 001. There we go. Serial 0/0/1 on R2. Then I'm looking for 2:2. Oh, that's right here. That's serial 001 on R1. Serial 0/0/1 on R1. And then the last one right here. Oh, I'm missing a double colon right there. I'm looking for a 1:A. 1:A is up right here. That is the NIC on PC1. Before we end this, I do want to show you something. Notice we went from G0. Oh, I need to come up here. I have to compare these together. Up here was IP version 4. Down here was IP version 6. Because the interfaces have both IP version 4 and IP version 6, commonly known as dual stack when you run both of them, IP version 4 and IP version 6. Because those interfaces have IP version 4 and IP version 6 assigned to it, the path was the same. The first one, as we went from PC1 to PC2 in our traceroute, was gig 00 on R1. That's what we have here, gig 00 on R1. The second one was serial 000 on R2, serial 00 on R2. The third one, serial 001 on R3. That's what we have right here. And finally, the last one, NIC on PC2, NIC on PC2. It followed the same path, it just used different protocols. And that's the end of our lab. That was Packet Tracer Lab 13.2.6, verify IP version 4 and IP version 6 addressing. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.